Alright everyone, this is a video about a word problem that has to do with solving an equation that has variables on both sides. So in this particular example, the question states that the value of the perimeter of the figure, which is a rectangle, is equal to the value of its area. So in order for us to solve this, the first thing we have to know is the formula for the perimeter of a rectangle, and of course the formula for the area of a rectangle. Just in case you forgot what those were, I'll help you out. It is 2 times the length plus 2 times the width for the perimeter, and the area of a rectangle is of course the length times the width. We'll go ahead and call this 6 inches the length, and we'll call this 2x inches the width over here on the side. So this problem is actually pretty simple. It just involves a little bit of substitution, a little bit of combining like terms, and of course getting all of our like variables to the same side. So let's go ahead and substitute in our variable, or substitute in our numbers and our length and our width for our variables in the p equals a equation over here. So I went ahead and did that here for us. 2 times the length, which is 6, plus 2 times the width, which is 2x, is equal to the length of 6 times the width of 2x. So let's take a moment here and simplify any like terms we have. 2 times 6 is, of course, 12, plus 2 times 2x, which is, of course, 4x. That is equal to 6 times 2x is 12x. Now, here comes the question. What do we have to do when we have variables on both sides? What's the first thing we do? Well, of course, we all know that we need to get all of the variables over to the same side. Now, we don't care if we take the 12x over here to the left, or if we go ahead and take this 4x and bring it over to the right. Either way, we will be able to find our answer, but it does make a little bit more sense to bring that 4x over to the right, because that would go ahead and leave our constant, the 12, by itself, and all of the variables on the other side. So that'll actually save us a little time if we bring this 4x over here. Now, in order for us to bring variables across an equal sign, we have to use something called inverse operations. So this 4 is being added to positive 4x, so of course that means that we need to use subtraction in order to bring it across. So let's do minus 4x here, minus 4x here, and that gives me 0. Over here, 12x minus 4x gives me 8x. And of course, very important for me to go ahead and rewrite everything that I have left beneath. I have 12 equals 8x. So I'm just about done this problem here, because all I have to do now is get my variable alone. And in order to do that, I of course once again need to use some inverse operations. 8 is being multiplied by x, so in order for me to make that coefficient a 1, I have to divide by that same coefficient of 8, because anything over itself is the number 1, and I can cross it out. Over here I do 12 divided by 8, and I can write my final answer. I'll do that over here on the side. I get x is equal to 12 over 8, and we know that 4 goes into both 12 and 8, so we can simplify that, and we can make that 3 over 2 equals x. And if we change 3 over 2 into a mixed number, that would of course be 1 and a half. Well, there you have it. 1 and a half, if I scroll back up here, is the value that x has to be in order for the perimeter to equal the area. Now, let's very quickly check that. If we plug 1 and a half in for x, 1 and a half times 2 is of course 3. So go ahead here and change this to 3. We did that because 1 and a half times 2 equals 3. And now we can check the perimeter. Well, the perimeter is when we add up 2 times the length, which is 12, plus 2 times the width, which would be 6. That equals 18. Now let's try doing 6 times 3, which would give me the area, and that also gives me 18. So it is true that our length, our perimeter equals the area, where the perimeter is 18 and the area is also 18. Always important to check our work. All right, thanks for watching, folks.